Hey guys, welcome back to Tutoring. My name is TL, and today I'm going to be going over some of the things you need to know in terms of geometry for the SAT2 Math Level 2 test. So let's begin. I'm just going to go over a couple of questions that I've pre-selected, and hopefully through my problem-solving process, you'll be able to pick up some of the things that you didn't previously learn or still need to practice in terms of the subject test. So in the first problem, it states that AB and BC are congruent and angle C is 40 degrees. And we're looking for X. So this is what we're looking for. Angle C is 40 degrees. So let me just put that in. And AB is congruent to BC. So now what we have is an isosceles triangle. Since this is congruent to BC, we know that angle A is also going to be 40 degrees because if we have isosceles triangle, we not only have two of the exact same base angles, but the sides are going to be equal as well. So yes, we have two 40-degree angles at the bottom, and now we're trying to look for angle B. So how do we solve for angle B? Well, it's basically just going to be using 180 minus 40 minus 40, or 100 degrees, because the sum of the angles in the triangle is 180 degrees. So now what we could do is use the law of sines. So this is the law of sines. So the capital letters represent the sides. So this is the side opposite of angle A, otherwise known as 10. And then the sine of that angle, which is 40 degrees. And then B, we don't know yet. That's what we're looking for. So we'll just put an X. And then we have the sine of 100 degrees on the bottom. So if we cross multiply, we get 10 sine 100 degrees is equal to X sine 40 degrees. And then we just divide that sine X sine 40 degrees over just to get X. And this we could just simply plug into the calculator. So if I pull out my calculator, we get 10 sine 100 over sine 40, and make sure that your calculator is in degree mode because in radians it'll give something completely different. So then we have 15.32 as our answer. Next, what we're going to do is set up relationships between diameter and height in order to find the height. So it says that diameter and height are going to be equal to each other, and the volume of cylinder is going to be pi r squared h. And what is diameter in terms of r? D is going to be 2r. So r is going to be equal to d over 2. And since d is equal to h, we just plug that in over here. R is equal to h over 2. And now we just plug it in back into this equation. B is equal to pi h over 2 squared times h. So we square that fraction, and we get h squared over 4 times h, or v is equal to pi h cubed 4. So they already gave us the volume, which is going to be 2, so we just plug that in. 2 is equal to pi h cubed over 4. 2 over pi is equal to h cubed over 4. And now we're just going to have 8 over pi is equal to h cubed. And lastly, what we need to do is take the cube root of 8 over pi, and then we get our answer. I just like to do my algebra before the calculator so I don't get a lot of mistakes, and we get 1.365 rounded to 1.37 as our answer. Next is talking about the ratio between two different volumes. So ratio of the volume between the smaller piece and the bigger piece. So let's see what information that they give us. Each has the same height. So we know that this is, we could just call this h, since they are going to be the same height. So this is going to be h, and then we also have another one on the bottom. So let me just change the color for that one. And this can even extend all the way up here to h. So let's find the volume of these two cones. So cone 1 is just going to be written in black. Cone 1. That's just going to be the standard equation. 1/3 pi r squared h. Now let's just assume that this is going to be r, because the bottom one is actually going to be 2r also. And why is that? It's because when I drew the height's going to be an altitude. So there's one angle that they share. And then the second angle that they share is this angle up top. They both share that angle. So it's going to be angle, angle. And they are similar triangles. So as a result, if h turns into 2h, then we know that r turns into 2r, because the first triangle is just going to be multiplied by a factor of 2. So here's our equation for the first volume and second cone is going to be v is equal to 1/3 r, and now we just plug in what r was, 2r squared times 2h. And this is in relation to the first, or the original cone on top. And we say 2r because it's just twice as big. Now, one thing we're missing is subtracting the original volume, because the top cone is not included in the volume calculation for the bottom part, so that's why we're subtracting it. Okay, so let's keep on solving this one. V is equal to 2 squared, 4, r squared, times 2h. So you could just multiply the constants. That's going to be 8r squared h pi times 1/3, otherwise known as 8/3 pi r squared h minus 1/3 pi r squared h. And that's just going to leave us with 7/3 pi r squared h. And now it's going to ask us for the ratio. So what we're going to do is put the smaller one over the bottom one. Yeah. Okay, they're both being divided by 3, so we can just cross that out. Pi's cancel, r squared cancels, and we also have that h that cancels. So the ratio of the volume is going to be 1/7 in terms of the smaller piece to the volume of the bigger piece. And that's our answer. Okay, so this last problem involves a bit of trigonometry. So if we have this given, sine theta is equal to 0.57, what we could do is do the sine inverse of 0.57 in order to find theta. So let's plug that into our calculator now. Sine inverse 0.57. Theta is equal to 34.75. So if we do 180 minus that value, and then we just take the sine of it, we'll get 0.57 again. And let me explain why that is for a second. So whenever we have angles that are going to be bigger than 90, what we do is just take the reference angle. And what is the reference angle? The reference angle is going to be the angle between the line and the x-axis. So if we have this angle, let's say this is 34.75, if we have 180 minus 34.75, we're left with 145.25. So that will probably look something like this. So now that we have those two lines plotted, we pretty much need to find this angle. So how we do that is, if this angle is 145.25, we just subtract it from 180. And then we get the same thing, 34.75. So when we're taking the sine or tan or cosine or whatever of an angle, what we actually need to take a look at is the reference angle. So these have the same reference angles. So they're just going to be the same magnitude. So the number's just going to stay the same. Now, what about the sine? Is it going to be positive or is it going to be negative? For that, we have to look at what quadrant these fall in. So if we're taking the sine of something and it falls within the first or second quadrant, then we know it's going to be positive. However, if it falls out of those quadrants, we know it's going to be negative. However, if we're talking about the tan, the first and third quadrant are going to be where tan is positive. And if we're talking about the cosine, we have the first and fourth where the cosine is going to be positive. So let's see. We know that the original value was positive, so either the first or second quadrant. And as a result, we're going to have a positive number. And then we also know, we just proved, that anything subtracted from 180, this data subtracted from 180 is just going to give you the same value for sine, just because if data is less than 180, then the supplementary angle will also give you the same value for sine. Because all we're looking for really is just this reference angle, which will be the same. So that's all I have for today. If you guys enjoyed the video, please be sure to like, comment, and subscribe to our channel. If you have any more questions, please leave them in the comments below. And if you want to be a student or tutor, there are links in the description where you can sign up. And see you guys next time.